In mathematics, a divisor of an integer, also called a factor of, is an integer that can be multiplied by some other integer to produce. Definition. Two versions of the definition of a divisor are commonplace. For integers, it is said that divides is a divisor of, or is a multiple of, and this is written as, if there exists an integer such that. Under this definition, the statement holds, as before, but with the additional constraint. Under this definition, the statement does not hold. In the remainder of this article, which definition is applied is indicated where this is significant. General. Divisors can be negative as well as positive, although sometimes the term is restricted to positive divisors. For example, there are 6 divisors of 4, they are 1, 2, 4, -1, -2, and -4, but only the positive ones would usually be mentioned. 1 and -1 divide every integer. Every integer is a divisor of itself. Every integer is a divisor of 0. Integers divisible by 2 are called even, and numbers not divisible by 2 are called odd. 1, -1, n and -n are known as the trivial divisors of n. A divisor of n that is not a trivial divisor is known as a non-trivial divisor. A non-zero integer with at least one non-trivial divisor is known as a composite number, while the units -1 and 1 and prime numbers have no non-trivial divisors. There are divisibility rules which allow one to recognize certain divisors of a number from the number's digits. The generalization can be said to be the concept of divisibility in any integral domain. Examples. 7 is a divisor of 42, because, so we can say. It can also be said that 42 is divisible by 7, 42 is a multiple of 7, 7 divides 42, or 7 is a factor of 42. The non-trivial divisors of 6 are 2, -2, 3, -3. The positive divisors of 42 are 1, 2, 3, 6, 7, 14, 21, 42. Because the set of all positive divisors of 60, partially ordered by divisibility, has the Hasse diagram. Further notions and facts. There are some elementary rules. If and then, i.e., divisibility is a transitive relation. If and then or if and then holds, as does. However, if and then does not always hold. If GCD, then. This is called Euclid's lemma. If is a prime number and then or, a positive divisor of which is different from is called the proper divisor or an aliquot partive. A number that does not evenly divide but leaves a remainder is called an aliquot partive. An integer whose only proper divisor is 1 is called a prime number. Equivalently, a prime number is a positive integer which has exactly 2 positive factors, 1 and itself. Any positive divisor of is a product of prime divisors of raised to some power. This is a consequence of the fundamental theorem of arithmetic. A number is said to be perfect if it equals the sum of its proper divisors, deficient if the sum of its proper divisors is less than, and abundant if this sum exceeds the total number of positive divisors of is a multiplicative function, meaning that when two numbers are relatively prime, then, for instance, the 8 divisors of 42 are 1, 2, 3, 6, 7, 14, 21 and 42. However, the number of positive divisors is not a totally multiplicative function. If the two numbers share a common divisor, then it might not be true that the sum of the positive divisors of is another multiplicative function. Both of these functions are examples of divisor functions. If the prime factorization of is given by, then the number of positive divisors of is and each of the divisors has the form where for each for every. Natural. Also, where is Euler-Mascheroni constant? One interpretation of this result is that a randomly chosen positive integer n has an expected number of divisors of about. In abstract algebra, given the definition for which holds, the relation of divisibility turns the set of non-negative integers into a partially ordered set, a complete distributive lattice. The largest element of this lattice is 0 and the smallest is 1. The MEET operation is given by the greatest common divisor and the join operation by the least common multiple. This lattice is isomorphic to the dual of the lattice of subgroups of the infinite cyclic group.